Hello, boys and girls. In the previous video, we have seen the various problems that can be asked in the straight line equation. Okay, so these are the various problem statements that we have seen, and we also seen how to solve such kind of problems on a straight line equation. Again, what is a straight line equation? A straight line equation is an algebraic equation which represents a straight line on a coordinated plane. What is a coordinated plane? A plane that is having an x-axis and a y-axis. Both are perpendicular and they are meeting at an origin. They are meeting at a point. That point is called an origin. Okay, so that is the straight line equation, and the straight line equation is also called a linear equation. Is also called a linear equation. See here, there is a line here in the linear. If you see the word carefully, there is a line. The linear equation is again a straight line equation. Is also a straight line equation which represents a straight line in a coordinated plane. Okay, so we have a few more problem. We're going to see few more problems that can be asked in the examination. For example, I will give you one straight line equation. Say the straight line equation, again it can be in y is equal to mx plus c format, or it can be something like a 2x plus 3y plus 5 is equal to 0. So all of them are a kind of a straight line equations. So I'll give you one straight line equation, and what you have to do is you have to draw that straight line on a coordinated plane. Okay, the equation that I'm going to give it to you is x plus 2y plus 4 is equal to 0. First of all, is this a straight line equation? Yes, we have already discussed here. Check if a given equation represents a straight line. Okay, so this is a straight line equation because the maximum power of x is 1. Maximum power of y is 1. And there are no x square terms, there is no xy terms. Okay, so this is a straight line equation, and there is also an is equal to symbol. Okay, every equation will have an is equal to symbol, and there are some set of unknown variables and some known constants. Okay, so this satisfies the criteria to be eligible for a straight line equation. Okay, now I gave you this equation, and in the exam they'll ask you, okay, this is the straight line equation, and draw this straight line on a coordinated plane. How will you draw it? Okay, the coordinated plane, you all know that it will be like this: x-axis horizontally, and a y-axis here vertically. Okay, and they both are going to meet at a center, and this is also called origin. Okay, and both x-axis and y-axis are perpendicular to each other. That means they make a 90 degrees angle here. Okay, now this is a straight line equation, and what you have to do is you have to draw this straight line on a coordinated plane, and that is the plane on which you have to draw this straight line. How will you do that then? Okay, to do that, what you have to do is you make some tabular form like this. Okay, now on the one row you take the values of x, on the other row you take values of y. Okay, for x, what I am taking is I am taking the initial value of 0. Okay, you can take, for that matter, you can take any value, but I am starting with the 0 because it makes our things little easier. Okay, so I am starting with the value of 0. Okay, now what you have to do is keep this 0 in this equation and solve for y. Okay, so I am doing it now here. So 0 plus 2 into y, 2y plus 4 is equal to 0. And y is equal to 2y is equal to 0 plus 4 is 4, and if I take that 4 to the other side, it's going to be minus 4, and y is equal to minus 4 by 2. Minus 4 by 2, which is equal to minus 2. Okay, y is equal to minus 4 by 2, which is equal to 2. I'm going to write a little bigger. Y is equal to minus 4 by 2, that is equal to minus 2. Okay, so now what is the value of y? It is minus 2. For a given x, when x is equal to 0, the y has become minus 2. Okay, This pair, the value of x and y, represent a single point. How do you represent a point in a coordinated plane? X comma y, some value of x comma some value of y, and they are closed in a parenthesis. Okay, so this is one point. 0 comma minus 2 is 1 point. Okay, now what you have to do, you take another value for x, which that can be any value. Okay, but you try to take the smaller value so that it will be easy for you to simplify things. Okay, the next value that I am taking for x is 1. Okay, again the same way whatever we did when x is equal to 0, the same thing we're going to do here when x is equal to 1. Okay, so I am keeping the value of x as 1 in this equation. This is the given equation. Okay, so the what we are doing is that equation is given and we are going to draw a line that is going to represent this equation. Okay, it's amazing, isn't it? An equation, an algebraic equation is given, and when you plot that equation on a coordinate plane, you are getting a straight line. Okay, now take the value of x as 1. Okay, I put 1 in place of x here. 2 into y plus 4 is equal to 0. Now when I sum up 1 plus 4, you'll get 5. Okay, 2y plus 5 is equal to 0. 2y is equal to, I'm going to take plus 5 into the other side, then you'll get 0 minus 5, and y is equal to, here 0 minus 5 is minus 5. The 2 if it goes to the other side, it's going to become minus 5 by 2. Okay, minus 5 by 2, which can also be written as minus 2 and a half. Minus 2 and a half. Okay. Okay, when the value of x is 1, we got a value of y as a minus 2 and a half. Okay, so this is going to represent another pair. This is another pair of x and y. That means this is going to represent another point on the straight line. What is the straight line? This is the straight line equation. Okay. Now you got 2 points. What are those points? This pair represent 1 point and this pair represent another point. We got 2 points. 2 points are enough. 2 points are enough. Usually enough. Like if you want to draw, you can draw with the 2 points. We discussed yesterday how many points will be there in a straight line. There will be infinite points. How many lines passes through given 2 lines? There is only one possibility. That possibility is there will only be one line that can pass through 2 given points. Okay. Okay. So you put any 2 points in this plane. Say you put 1 point here, 1 point here. So there will only be one straight line that passes through these 2 points. Okay. Now, sorry. What is the value? What is the equation that we took? 2x plus 2y plus 4 is equal to 0. This is what we taken, right? Let me put it here again. If I put this one, this, yeah, correct. Yeah, if I put 1, 5, yeah, it's correct. Yeah. Now I'm going to take the value of x as a 2 here. Okay. So now I'm putting the value of x as 2 here in this equation. 2 plus 2y plus 4 is equal to 0. When I simplify this one, you'll get 2y plus 6 is equal to 0, because 2 plus 4 is 6. Okay, and 2y remain 2y here and is equal to 0 is equal to 0. Okay, 2y is equal to 0 minus 6. So if a 6 goes to the other side, we'll get a minus 6. And y is equal to minus 6 by 2, which is equal to minus 3. Okay, minus 3. Now we got a 3 points. This is 1 point, x comma y. This is another point. This is another point. Okay. Now you spot these 3 points on the coordinated plane. The equation is x plus 2y plus 4 is equal to 0. Spot these 2 points on the coordinated plane. This is the coordinated plane. Okay, and these are the 3 points we got it. So what is the first point? 0 comma minus 2. Where is 0? How can you spot this point 0 comma minus 2? The x coordinate it is 0 and the y coordinate it is minus 2. So it will be, say for example, if I put minus 1, minus 2, minus 3, minus 4, minus 5 on this side, 1, 2, 3, 4, 5. And on this side of x-axis, you'll get -1, -2, -3, -4, -5. And on the y-axis, you're going to have 1, 2, 3, 4, 5, 6. Okay, so the first point is 0, -2. The 0, -2 is, this is the point. Okay, the point is 0, -2. What is the next point? The next point is 1, 0, -2. This is one point, and the next point is 1, -2.5. Where is 1, -2.5? 1 is here, and 2.5 is somewhere here between -2 and -3. Okay, so this point I'll put it on the side, 0, -2, and the other point is 1, -2.5. 1 here and 2.5 will be somewhere between -2 and -3. This point, see, this is one point, this is the second point, and where, okay, and this point represents 1, -2.5. What is the third point? The third point is 2, -3. Where does the point lie? Here, 2, -3. So it will be here. So on the x-axis it is 2, on the y-axis it should be -3. So this is the point. Okay, so this is the point that represents 2, -3. Now we got 3 points. What you have to do is just to take one scale and connect all these 3 points. Okay. As long as possible on the given graph. Okay. Okay. So that's how you have to draw a straight line when an equation is given. Okay. Now what are the few things that we can do? At what point is it meeting y-axis? It's meeting at a point 0, -2. Okay. If you convert this one into y is equal to mx plus c format, you will get a -2 for c. Okay. What is the slope of this one? Is it a positive slope or negative slope? Because as it passes from left to right, it is falling down. The line is falling down. So it is going to have a negative slope, which means m you will get as a negative m. The value of m will be a negative number. Okay. So if you want, you can again bring this equation into y is equal to mx plus c format and see whether whatever I said is true or not. Okay. So now x plus 2y plus 4 is equal. Okay, I'll do one thing. I'll write here x plus 2y plus 4 is equal to 0. So 2y will be here. I'm taking x and plus 4 to the other side. It will be minus x minus 4, and y will be minus x by 2 minus 4 by 2. Okay, if you further simplify it, you'll get minus half x. Minus x by 2 can also be written as minus half x. Minus 4 by 2 is minus 2. So, what is m here? M is minus half. This is minus half is a negative number. It is not a positive number. Minus half is a negative number. So, that is why you saw the line falling while it is moving from left to right. The line is falling down. And at what point it meant y-axis? It meant y-axis at minus 2. At minus 2. So this is C here. What is C here? What is the generic formula for straight line equation? Like in the form of slope intercept form. Y is equal to mx plus c, where m is the slope and c is the point at which it meets the y-axis. So in this case, see here minus 2. We got a c as a minus 2. So yeah, this line met y-axis at minus 2. Okay. Yeah, that's how you have to do. So what did we solve now? In straight line equation is given. This is the equation that is given, and you are asked to draw a straight line that represents this equation in a coordinated plane. That's what we have done it. Okay. So you take a value of x as 0, find out y. Take a value of x as 1, find out y. Take a value of x as 2, you find out y. So these pairs represents a point, like each pair will represent a 1 point. So spot those points in the coordinated plane and take your scale and draw a straight line connecting all those 3 points. All right, yeah. And okay, there will also be question asked like a straight line equation is given and they'll ask at what point that straight line will meet an x-axis. The y-axis we already found here, -2, and we also proven using this y is equal to mx plus c format. When we rewrite this equation in y is equal to mx plus c format, we found the value of c as a -2, which means it is meeting y-axis at a -2. To be precise, the point is 0, -2. This point on the y-axis is 0, -2. Okay, so this is the equation given, and a question is asked at what point it meets the x-axis. It is meeting at x-axis. At what point it is meeting? Somewhere here, isn't it? So without drawing this straight line, how will you find out at what point it is meeting x-axis? Okay. To know that, what you have to do is, so this is the given equation. Okay, if a line to meet the x-axis, what you have to do is you have to put value of y as a 0 in the given equation. Okay, every point on the x-axis, so this is an x-axis, at every point, x-axis is a line, right? It is an axis, but at the same time this is also a line. At every point, you pick up any point on the x-axis, the value of y is 0. On the y-axis, you pick up any point on the y-axis, the value of x is 0. That is why we got a point 0, -2. 0 is the x coordinate and -2 is the y coordinate. Okay, this point will be 0, -3. This point will be 0, -4. This point will be 0, -5. Okay, so one rule is that on every point on the x-axis, the value of y will be 0. That is why we are putting y as a 0. What is the question here? Straight line equation is given and you are asked to find at what point it meets the x-axis. Okay, to find out the point at which it meets the x-axis, what you have to do is put the value of y as a 0. X plus 2, 2 into 0, 2 into 0, that is 0. Okay, I'll elaborate it. 2 into 0 plus 4 is equal to 0. So x plus 0 plus 4 is equal to 0, which is equal to x. If you simplify this one, 0 plus 4 is 4. And if you take that 4 to the other side, 0 minus 4, that will be -4. Okay, so now you got an x as a -4. So what is the point? The point is y you already replaced as 0. The point is -4, 0. Okay. Okay, if you draw this line with the proper scale and the proper graph, this is going to meet like this. This will go like this. Okay, so previously it was drawn with a free hand, that's why there was a mistake. But if you take a proper scale and a proper graph paper, if you plot these points and draw a graph, you will see this line is going to meet x-axis at a -4. Exactly, it's going to meet at a -4. Okay, if you want, you can take a graph paper and do this experiment by your own, and you will notice that it is going to meet at a -4 on the x-axis. Okay, two things we have seen. Straight line equation is given, and you are asked to find out at what point it's going to meet the x-axis. Okay, there will also be questions like a straight line equation is given and they'll ask what is the area of a triangle. Okay, what is the area of a triangle that is formed by area of a triangle that is formed by x-axis, y-axis and the line. Okay, in this case, where is the triangle? This is an x-axis, this is an y-axis, and this is the line. Where is the triangle? So this is the triangle, right? So if you see here, this is the triangle. This is part of x-axis, this is part of y-axis, and this is part of the line. Okay, so this is the triangle. Okay, if you want, I can shade it here. Okay, so that is a triangle. What kind of triangle is it? It's a right angle triangle because angle between x-axis and y-axis is always a 90 degrees. Okay. Yeah. To find out what is the area of a triangle? Area of a triangle is half into area of a triangle is half into base into height. B represents the base, H represents the height. So what is the base here? What is the base here? Base, you can consider this as a base and this one you can consider it as a height, or else you can consider this part as a base and you can consider this part as a height. In either way you're going to get the same answer. Okay, so to find out the base, what you have to do is, to find out the base and height, the very first thing that you have to do is, you have to find out at what point it is going to meet x-axis and at what point it is going to meet the y-axis. Those two things we have seen in the previous problems. Okay, we found it ourselves, like at what point it is meeting a y-axis, at what point it is meeting x-axis. And yeah, so when we rewrite this equation y is equal to mx plus c format, we found c as a -2. That means it is meeting y-axis at -2. And previously we also saw at what point it is going to meet x-axis by keeping y as in 0. Okay, so by doing so we found it's meeting y-axis at -2, it is meeting x-axis at -4. So now what is the length of this base? Consider this as a base, consider this as a height. What is the length of this base? The length of this base is 2 units. Say here we started from origin -1, -2. The length is always a positive number. It can never be a negative number. So the length is 2 units. Half into base is 2 into what is height? Height is from here to here. This is the height. Okay. So this is the base. This is the height. If you treat this triangle like this, you will get a proper triangle with a proper base and proper height. Okay, so the height in this case is going to be 4. Though it is -4, you should not put a -4 because the lengths will never be a negative number. So you put a value of 4. Okay, 2 units here and here it is a 4 units. Okay, so 2 gets cancelled and 4 unit into unit square units. Okay, which is the units per area. Okay, so yeah, the area of a triangle that is formed by x-axis, y-axis, and the given line equation in this case is 4 square units. That's how you have to find it out. The very first thing you have to do is that you have to draw the line on a coordinated plane and find out at what point it is meeting x-axis, at what point it is meeting y-axis, and then from there you visualize what is base, what is height, and then keep this base, value of base and value of a height into this formula, which is half into base into height, and you'll get the area of a triangle. Even if you consider this as a base, if this is the height, you'll get the same answer, because instead of putting 2, instead of 2 here, you're going to put 2, instead of 4, you're going to put a 2 there. So it's going to give you the same answer. Okay, fine. Next question is, a straight line equation is given and you'll be asked whether it passes through origin or not. Okay. To find out whether a given line passes through origin or not, it's very simple. So what is the point for origin? It is 0, 0. Okay, 0, 0. That means when you put a value of x as a 0, you should get the value of y also as a 0. Okay, when you put a value of x as a 0, you'll also get the value of y as a 0. So let's put a value of x as 0. We already put value of x as 0. When we put a value of x as 0, we got a value of y as a -2, which means it is not passing through origin. Okay, for every straight line that passes through origin, this value of c will be 0. For example, if I tell y is equal to 5x, this is the line that is going to pass through origin because there is no c here. This is in y is equal to mx plus c format. But is there a c? There is no c. In that case, you can assume c as a 0, plus 0. So there is no value of the c here. So that's why it passes through origin. It passes through origin. Yeah. Otherwise, if a equation is given in this format, you put a value of x as in 0. 0 plus 2y plus 4 is equal to 0. When you solve it, you will get a minus 2. 0 comma minus 2. So that is why it is not passing through origin. Which means there is a some c here. There is a c. There is some value for c. That is why it is not passing through origin. Alright. What are the other problems that can be asked in the linear equation and a straight line equation? Okay, so the next kind of problems that we asked are, there are two line equations are given. At what point they are going to meet. Okay. Okay, so I'm going to give you y is equal to 7x plus 6. This is one straight line equation, and another one is y is equal to 7x plus 9. Okay, I gave you two straight line equations, 7x plus 6 and 7x plus 9. Y is equal to 7x plus 6, and what you have to do is you have to find out at what point they are going to meet. Okay, there are two lines on a plane. They can meet, right? At some point. Okay, at what point they are going to meet? Now, first of all, will they meet at all? So what is the condition for a given two lines not meeting at all? Okay, the condition is their slope should be same. If their slopes are same, we have discussed yesterday here. What is that? Check if the two given lines are parallel or not. These are the two given lines. Are they parallel or not? They are parallel because they both have the same slope. The slope in this for this line is 7. The slope for this line is 7. So they are not going to meet at all. They are never going to meet. They're never going to meet. Okay. So how is this going to look like? Here it is 6. So if I put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this line will go, because this is a positive slope, it goes this way, something like this, and this line will go like this. That will be exactly parallel to this one, because in both cases the slope is same. They're not going to meet. Okay, so there's no point in finding out at what point they're going to meet. But otherwise, if a two lines whose slopes are not the same, say the slope is here is 6. If the slope here is 7, if the slope for this equation is 6, then they are going to meet. Certainly they are going to meet at some point. Okay, if not here, but somewhere down up there or down here, they are going to meet. They are surely going to meet if their slopes are not equal. Okay, let us see an equation. Let us take a couple of equations and see at what point they are going to meet. Y is equal to 2x plus 5. This is one equation that represents one straight line. Another one is y is equal to 3x minus 2. Okay, this is another straight line equation. Okay, will they meet? They will meet. Surely they will meet because the slope here is 2, the slope here is 3. The slopes are different. They are going to meet. Surely they are going to meet. Okay, let's make a rough sketch of this. Rough sketch of these two straight lines, and we'll see roughly at what point they are going to meet. If you have a proper graph paper, you can even make it more nicer way. Okay. How do you find it out? Again, the same way whatever we previously discussed. Put the value of x as 0. Find out the value of y. Okay, so I'll do that one for the first equation. I'm going to put value of x as 0. When I put value of x as 0, I'll get value of y as a 5 because 2 zeros are 0 plus 5 is 5. And when I put value of x as 1, I'll get value of y as a 7. When I put value of x as a 2, I'll get value of y as a 9. Okay, so these are the various points 0, comma 5, 1, comma 7, 2, comma 9. Okay, these are 3 points that lies on this line. Okay, if you plot the straight line using these points, you'll get 1, 2, 3, 4, 5, 6, 7, and similarly here on this side you'll get 1, 2, 3, 4, 5, 6, 7. Similarly on the downside of y-axis you will have -1, -2, -3, -4, -5, -6. Similarly on this side you will have -1, -2, -3, -4, -5, -6. Okay, so 0, comma 5, where is that point? That point is here because any point on y-axis, for that point the x coordinate value is 0. Okay, 0, comma 5 is this point, and 1, comma 7 should be somewhere here, and 2, comma 9 will be somewhere up here. Okay, if I take this one, yeah, somewhere up here. Okay, so connecting all these 3 points, I'm drawing a line. Yeah, okay. So that is the first equation that we have drawn. And the second equation, again, we're going to make a similar table. Okay, so this is extending, it is rising. That is why we got a positive slope. So that is correct. And it is also meeting at a point 5. On y-axis, it is meeting at 5. So both are satisfied, and the line is drawn like this, a rough line. Okay, rough line. Yeah, for the second equation, you put a value of x. Again, the similar kind of table you prepare. Put a value of x as 0. Find out what the value of y. When you put x as 0, you will get y as -2. When you put x as 1, 3 into 1, 3, -2, you will get 1. When you put value of x as 2, 3 2s are 6, 6 minus 2 is 4. 4. Okay, so these are the 3 points we got for the second line. This is the first line, this is the second line. This is the first line, second line. For the first line, these are the coordinates. These are the 3 points we found. For the second line, these are the 3 points we found. Okay, let us point or place these points on the coordinate plane. 0, comma -2. Where is this? 0, comma -2. Again, on y-axis, every point will have a 0 coordinate as 0. Sorry, x coordinate as a 0. That is one point. And the second point is 1, comma 1. Where is 1, comma 1? 1, comma 1 is here. Where is the third point? 2, comma 4. 2, comma 4. Yeah, here. Okay. Okay, when you draw the straight line representing the second equation, it goes like this. Again, let's validate this one. It's having a positive slope, so it goes, while it is moving from left to right, it rises, and the value of c is -2. This is -2. Okay, -2, and yeah, both are satisfied, and they're going to meet these two lines. Because those two slopes are not same, they're certainly going to meet at some point, and that point lies somewhere here. Assuming that if this is the point that it is going to meet. Okay, this is not so accurate, but if you draw the same thing in a graph, you'll perfectly get a nice straight lines, a beautiful straight lines. Okay, at what point they're going to meet? They're going to meet roughly around, say, 3, say 3, comma 10 or somewhere. Okay, 3, comma 10. Okay, so this is the point at which they are going to meet. Okay, that's only rough estimation, but if you properly draw this graph, draw these lines in a graph paper, you will get a precise points like whether it is 3.1, 3.2 or 3.3, whatever it is, you will get those precise points. Take one graph paper, plot these points and use your scale and connect all those points and extend it as far as they can go and see at what point they're going to meet. Okay, so this is the point. This is the point. If you put that point, this point is going to satisfy this equation and this equation. In this point, if you put 3, you will get the value of phi as 10. You may not get because this is only rough estimation, so that's why there's no point in verifying it again. But this is the point that is going to satisfy this equation and this equation. Okay, so there is also a topic called solving simultaneous equations that basically talks about how to solve if two equations containing two variables are given. In this case, there are two variables, x is one variable and y is another variable. To solve value of x and y, we need two equations. Certainly, we need two equations. So these are the two equations given, and we're going to solve the value of x and y using the simultaneous equations. That's a different chapter. There's a procedure, defined procedure how to solve simultaneous equations. But if using these straight line equations and the graph paper, this is how you have to find out the point at which they are going to meet. Okay, and the next possible questions that can be asked is, a straight line is given, a straight line equation is given, a straight line equation. For example, y is equal to 5x minus 8 is minus 8. A straight line equation is given and a point is given. A point, for example, like 2 comma 4. Okay, say we have a coordinated plane like this. This is an x-axis, y-axis, and there is one straight line that is going like this, and there is a point somewhere here. Okay, okay. So you'll be asked, what is the perpendicular distance? How do you find out the perpendicular distance? First of all, what is the perpendicular distance? Okay, this is a line and this is the point. What is the perpendicular distance? You draw a line that is perpendicular to this one, perpendicular to the given line, and passing through this point. Okay, so this is a perpendicular line that is passing through this point. So this distance from this point is called the perpendicular distance. There is a formula to find out. First thing, you have to convert this equation is in the form of slope-intercept form. You bring it into the form like ax plus by plus c is equal to 0. How to bring it? You bring everything onto the one side. Okay, so y minus 5x plus 8 is equal to 0. Okay, I brought 5x to this side and minus 8 to this side. Okay, it has become minus 5x, minus 8 has become plus 8 is equal to 0. Okay, you slightly rewrite it so that you put a x term first and then y term and then constant. Okay, this is how you can rewrite this equation. Now we got ax plus by. B is 1 here. By plus c is equal to 0. Okay, and what is the point? The point is 2 comma 4. So the formula here is that equation in this, when the equation in this form is given, this form is, this is not a y is equal to mx plus c form. This is a something like a ax plus by plus c is equal to 0. That is the form that is in this form. This equation is in that form. Okay, and this is the point, some point, and you need to find out the perpendicular distance. How do you find out the perpendicular distance? This is the procedure. This is the formula. Ax plus by plus c modulus. Modulus as in, even if you get the value as minus, you need to consider that as a positive value, by square root of A square plus B square. Okay, so this is the formula. Now let us see. So this is an equation. Original equation given is this one, and you converted in, you just rewritten that same equation so that we got everything onto the one side, and you brought everything to the one side, and on the other side we have 0. Okay, so this is the one, this is the formula. What is A here? A is -5. What is B here? 1. Okay, 1. What is C here? 8. Okay, what is X here? X is 2. What is Y here? 4. Okay, so you substitute those values. -5, A is -5 into 2 plus B is 1. B is 1 here, and the value of Y is 4. And what is C? C is 8. You put this one in under modulus. Modulus is used to consider only the positive, only the magnitude of it. Okay, we don't bother about the signs, whether it is positive or negative, we don't bother about it. Square root of A square plus B square. What is A square? 5 square minus 5 square. You will get a 25. Plus B square. What is the B square? 1 square. That is 1. Okay, when you further simplify it, you will get -10 plus -10 plus 4 plus 8 under modulus again. Square divided by square root of 26. When you further simplify, you got a 2. Okay, -10 plus 4 plus 8. When you simplify it, you get a 2 by square root of 26. Yeah. So this is the distance. You can use your calculator and you can further simplify, find out the value of square root of 26, and you divide 2 with that number. You will get some value, and that is the distance, that is the perpendicular distance between this line and this point. Okay, yeah. All right, yeah. So these are the various questions that can be asked in examination. The very popular form of the straight line equation is y is equal to mx plus c. It is very popular. By looking at that equation, you can visualize yourself how that line is going based on the value of m. If m is a positive number, it goes from left to right. When it is moving from left to right, it rises, and if the value of m is a negative number, when it is moving from left to right, that line falls, keep falling, and the C represents the y-intercept. Yeah. So various things we have discussed. Check if two given lines are parallel or not. Those two lines are said to be in parallel if their slopes are same. If the slopes are same, they are parallel, which means they are not going to meet at all. Never. Like even if you extend for an infinite distance, they are not going to meet at all. Check if two given lines are perpendicular or not. Okay, so what is the condition for a given two lines to be perpendicular? Their slopes should be additive inverse. What is additive inverse? Additive inverse is, say for example, for the first line you got a slope as a 5. If the other line is having a slope of -5, those two lines are said to be in perpendicular, because 5 and -5 are additive inverse. When you sum up those two, you will get a 0. 5 plus of -5 is 0. Okay. Given the line equations and find out the quadrants through which it passes. A line equation is given, and you need to find out the quadrants through which it passes. For that, again, write this equation y is equal to mx plus c format. Find out what the value of m is. Find out the point at which it meets the y-axis. So you get some rough estimation of how that line passes through, and based on that you can tell. Say for example, a straight line here. So if this line is passing, so this is having a positive slope because it is rising, and this is meeting y-axis at somewhere here, say for example 2, 0, 2. Okay, so if you know the slope, the slope whether it is a positive number or a negative number, and if you know the point at which it meets, you can simply tell it what are the quadrants it passes through. In this case, this line is passing through first quadrant, second quadrant, and third quadrant. What is the first quadrant? First, this part is the first quadrant. This part is second quadrant. Assuming this is an x-axis, this is an y-axis. Yeah, so this part is first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay, in this case, this line is passing through first, second, and third quadrant. Equation of x-axis is y is equal to 0. You should simply remember it. Okay, equation of x-axis is y is equal to 0. Equation of y-axis is x is equal to 0. Okay, every horizontal line on the coordinated plane will have a slope of 0. Every vertical line will have a slope of infinite. Okay, infinite slope. Every vertical line on the coordinated plane. This is x-axis, this is y-axis. So if I draw somewhere here a line whose slope will be infinite. Okay, because within no time this is rising infinitely, like it is going infinitely. So that is why the slope of that one is infinite. Okay. So what is the equation? Say for example, if it is meeting x-axis at a 5, 5, 0, what is the equation of that line? Equation of that line is x is 5, because you pick, this is the line equation for this line, because you pick any place on the line, value of x is 5 only, no matter what the value of y is. You don't care what the y is. Okay, but at every point on this line, x is equal to y, so x is equal to 5. So x is equal to 5 itself is the line equation for this line, that is in vertically, like here. The slope of this line is infinite because this is a vertical line. This is a vertical line. Yeah. Alright, we also seen a straight line equation is given, and you need to draw that straight line on a coordinated plane. We already discussed. You prepare a small table and put value of x as 0, x as 1, x as 2, and find out the value of y. Find out the value of y by keeping these x values into the given equation. Find out the value of y. Thereby we will get 3 points. This is 1 point, this is another point, this is the other point. Yeah. So place those 3 points in the coordinate plane, and connect all those 3 points using your ruler or a scale. Okay. So line, whether it passes through origin or not, the value of c should be 0. Okay, if the value of c is 0, then that line passes through origin. Okay, so if 2 lines are given, where do they meet? It's simple, like take a graph paper. Okay, draw the given 2 lines and extend as much as you can and see at what point they are meeting. If the slopes are not equal, surely they are going to meet. Certainly they are going to meet. If not here, they may meet somewhere down up there or down here, because the line will extend on both sides to an infinite level. Okay, so it may not meet on your graph paper, but if you continue to extend that line beyond your graph paper, they are going to meet. Okay, so there is a chapter called Simultaneous Equations, whereby we learn how to solve the value of x and y when 2 linear equations are given. Straight line equation is also called a linear equation because that represents a line. Straight line equation will never have x square term, will never have a y square term, will never have a x square term, or x cube term, or x to the power of 4 term. It only has x term or a y term or combination of both, or both terms and a constant. Okay, that constant can even be 0. For example, x plus y is equal to 0. Is this a straight line equation? Yes, it is a straight line equation. Okay, so there is an x term, there is a y term, and there is a constant. 0 can be constant. Okay, but they should be is equal to symbol. Say if somebody is given 2x plus 3y, is it a straight line equation? It is not an equation because there is no equal to symbol. It is not a straight line equation. It is just an expression. Okay, it's not making, you cannot draw it. You cannot draw that straight line using that expression. You need to have a equation. Okay, and we have also seen if straight line equation is given, what is the area of triangle that is formed by x-axis, y-axis, and that straight line. Okay, say this is y-axis and this is an x-axis. Okay, and this is the straight line, given straight line. Okay, so what is the area of a triangle? First of all, where is the triangle? This is the triangle. This is y-axis, this is x-axis, and this is a hypotenuse for this triangle. Okay. Okay. Yeah. So to find out the area of triangle, you have to first find out the base. You have to find out the height, and put the value of base and height into the formula of that area of a triangle formula, which is half into base into height. Okay, so in this case, this will be base and this will be height. Or alternatively, this one you can consider as a base and this one you can consider as a height. Either way, you're going to get the same answer. Okay, now you tell me what is the scenario in which we won't get any area? There won't. Okay, scenario in which we won't get any area for such a triangle. What is that scenario? There is a scenario if that straight line passes through origin. Okay, so there is no triangle formed here, right? There is no triangle being formed here. It is simply passing through origin. There is no triangle here. Okay, when value of C is 0, there won't be any triangle. So the area of a triangle will be 0. Alright, yeah, the perpendicular distance, a given line, straight line equation, you have to convert this one into this format. Ax plus by plus c is equal to 0. First, convert this one. If it is already given in this format, that is fine, well and good. Okay, there's nothing much to worry. But if straight line equation is given in this format, convert this one into this format, ax plus by plus c is equal to 0, and use this formula, ax plus by plus c is equal to ax plus by plus c under modulus by square root of a square plus b square. What is a here? This is a, and the coefficient of x is a, coefficient of y is b. What is x and y? X and y is the point. In this case, the point 2, 4 is given. 2, 4 is given, and you put 2 in place of x, you put 4 in place of y, and you compute that, you simplify that fraction, and you will get some units, and that units represents the length of the perpendicular distance. Okay, perpendicular distance. Like, say for example, if this is the line and if this is the point, this will be the perpendicular distance. Okay, what is the perpendicular distance? Draw some line from this line to this one. That should be perpendicular to this given line. Okay, that is the perpendicular distance. You can also draw a line like this, but this is not a perpendicular distance because it is not making a 90 degrees angle to the given line with the given line. Okay, so this is only the perpendicular distance. There will only be one perpendicular distance possible. Okay, before we wind it up, there is one more thing I want to tell you, that is a line segment. A line equation, we know that line will extend on both sides to an infinite level. Okay, it will never stop. What if, say, I'm going to give you one straight line equation, which is y is equal to 2x plus 5. Okay, let's draw that straight line very quickly. Again, the same table, popular table. So put the value of x as 0, you will get value of y as 5. When you put the value of x as 1, you will get a value of y as 7. When you put the value of x as 2, you will get a value of y as 9. Okay. Okay. Spot these 3 points. Put these 3 points in the coordinate plane. X and y, 0, 5, which will be somewhere, say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 0 comma 5 will be here, 1 comma 7 will be 1, 2, 3, 4, 5. 1 comma 7 will be somewhere here. The other one is 2 comma 9. Say 1 comma 7 and 2 comma 9 will be here. Okay, so I'm going to draw a straight line connecting this. Okay, this is a line. Okay, this is an equation, and when you plot it on the graph, you got a line that is going on both sides, that is extending both sides, that side and this side, to an infinite level. Okay, they're not going to stop anywhere. Okay, so I want you to give a line segment equation that represents only this portion of this line. A line segment has some definite endpoints. Okay, it will not extend on both sides. If I ask you to represent a line segment from this point to this point, how will you do that? Okay, so this is the line equation that represents the line. That means it represents every point on the line. It goes on both sides to an infinite level. So if I ask you to represent only this portion of the line, how will you do that? Okay, so there is a way of writing the line segment equation that is nothing but very same thing, the very same equation, where you have to put a condition. Condition is, what is the value of x? The value of x within this line segment. Value of x is 0, and what is the maximum value of x? 2. Okay. Beyond 2, it is not going. The line segment is not going, and before 0 also it is not extending. So it is only extended between the values of 0 and 2. So this is the same equation, and in addition to this equation, if you write a condition like this, 0 comma 2, something like this, if you write 0 less than or equal to x less than or equal to 2, okay, there is an equation and also there is a condition. This equation should be satisfied, at the same time this condition also should be satisfied. Okay, when such things are written, those things will typically represent, say, line segments. Line segment has a definite endpoint. Unlike line, it will not extend, it will stop somewhere. At what point it is stopping? It is stopping at when x is equal to 0, it is stopping. Say here x is equal to 0, it stopped. So that's why we put an endpoint here. This is x is 0, and when x is equal to 2, this is that endpoint and it is stopped. So this is only the one. A line segment is only this one. Okay, yeah, that's a line segment we have drawn. All right, yeah, so these are the possible questions that can be asked in a straight line. Yeah, so other than that, I don't think there will be any other kind of questions that are possible, first of all. Okay, so these are only the various questions that can be framed using this equation. It's an equation, the equation is given, line can be drawn, a line is given, and the equation can be derived. Okay, so yeah, check if a given equation represents a straight line or not. Given straight line, find its slope and intercept. Yep, that's pretty much it. All right, yeah, we conclude this chapter with this, and yes, yeah, we covered everything in this chapter. Thank you very much. Bye bye.